Hey, what's going on, everybody? Mr. Cornell here, ready to go over some sinusoidal modeling with you. I'm kind of looking at some real-world problems and how they use these sine and cosine models and what it does for them. All right, so let's recap everything that we've done so far and make sure that you have everything you need down. So here are some notes to make sure that you know how to use the graphing calculator. Make sure that it is in radian mode, so remember, hit that mode button, go down over to radian, make sure it's there and not in degree mode. Identify your critical info, that would be your maxes and your mins to help with your window. Remember that you're kind of usually going around that, for the x's, you're hitting that pi button, whether you're going to 2 pi or 4 pi. Sketch it on paper using some of those critical values, and then label everything, which we're going to take a look at today. So here it is. Here is your model for your sine and your cosine. It's a sine bx plus c. Okay, now each one of these has a meaning. So this first value in front of your function would be called the amplitude. And remember, we're going to use the absolute value of a. And the amplitude is basically saying how high or how low that the graph would be going. Okay, amplitude. And that's your distance from your midline. Distance from midline. Okay, so it doesn't matter if there was a shift or if it's not a shift. The amplitude, okay, it's showing you how high or how low you're going from wherever the midline may or may not be. Okay, then you have your C value here, and then that is the midline. Okay, so if that C value is 0, the midline would be there. If it said +2, okay, then that midline would be up here at the +2, and it would be something like that. So we're going to write the midline, or the average of the y values. Average of y values. Okay, and that would be like your max or your min there. Okay, then you have your B is the frequency of the model. Okay. That's right here. That would be inside frequency of the model. And remember, that is going to tell us the period by using the formula 2 pi over b. Okay. Midline, we just talked about that. That's the average of the y values. Then you have your period. It's the minimum distance along the x-axis for cycle to repeat. Okay. All right. So minimum distance along the x-axis for cycle to repeat. Now basically what that means in English, okay, is they're telling you how long it's going to take to complete that one cosine or that one sine. So it could take 2 pi to complete, it could take pi over 2 to complete, which means if I was completing a period of pi over 2, I would have to fit all of that in within one cycle there. Okay, your minimum value, that's your lowest y value. And then your maximum is your highest y value. And those come in handy when you're looking for your C value here. Okay. All right, so now let's kind of put all of this to use here. So for the first question, the tides in a particular bay can be modeled with an equation of D equals A cosine BT plus C, where T represents the number of hours since high tide, and D represents the depth of water in the bay. The maximum depth of the water is 36 feet. The minimum depth is 22 feet, and high tide hits every 12 hours. Okay? So here they want us to figure out the A, the B, and the C, the amplitude, the frequency, and your shift, your C value, okay, your midline. So let's start with our amplitude. Remember, the amplitude is the highest and lowest value that was achieved in the graph. So in this question, they said the maximum depth of the water is 36, and the minimum depth of the water is 22. So those are our highest and lowest values. So what I'm going to do is I'm going to find the 36 minus 22 divided by 2. Okay, so we're subtracting the highest and lowest value, which is 14 over 2, which is 7. Okay, so basically, we'll get, by definition, amplitude, distance from the midline, so it's going as high as up 7 feet and as low as down 7 feet. Okay, that figures out our A value. Now, our C value is going to use those same value, those same numbers. Okay, since I have my highest and lowest point, except now what you're going to do is you're going to find its average. So you're going to add those two numbers up and then divide that by 2. And then that is going to give you 29. Okay, so that's going to tell you where your midline is. So then this line here, if you say you were graphing it, would be right around there, like say like 29. And then our final one, which is our period. Now, they're telling me in this question that every 12 hours is basically when you're going to complete your cosine, right? So your period would be, say, 2 pi over b. So since the frequency is every 12 hours, you're going to be doing 2 pi over 12 or pi over 6, all right? So that gives us the A, the B, and the C. So now on the axis below, sketch the graph of this scenario for 2 full periods. Label the points on this curve that represent the high and low tide, and verify your answers and sketch are correct on your calculator. So if we're going to verify the sketch on the calculator, we'd have to put this into an equation, right? So let's substitute our A, B, and C. So the A would be 7 cosine. The B is, we said, pi over 6. And then that's our period there, x, plus our midline, which was 29. Now, the computer I'm using doesn't have that calculator on there, but when you should throw it into your calculator, if you're going to look at this, your x min would have been 0. Okay, that's where you're starting here. Your x max would be how far you're going to go. So if you think about it, to complete one cycle would be pi over 6. And they wanted 2 cycles, so your x max would be 2 pi over 6, or pi over 3 if you simplified it. By the scale, you can go by pi over 2. Let's see, now your y minimum, okay, that would be your lowest value of the graph. You could kind of leave that as 0, but we knew in this one that the lowest was 22, so you can kind of change that a little bit too if you wanted to maybe not look at, say, 0 to 10 or 0 to 15. So you can either do 0 if you wanted to leave it, or you can have it go up a little bit at 15. Then you have your y max, and that was the highest. Now, what was the highest in this graph? Well, the highest point in this graph was 36, so I would say go by 40. And maybe just count by 2s. So your scale would be by 2. You'll hit the graph, and you're going to get what I'm about to show you right now. So, in this graph, it is a cosine function. So I want to have in my head that this is what the graph is going to look like, right? And then since they wanted 2 cycles, I would then have to complete it again. So I knew that this is kind of what I'm going to be looking at. My midline is going to be 29, right? So if I'm going to sketch that here, this would be at y equals 29. That's my midline. Then you had to go up 7 from there and down 7 from there. And that would have been your maximum, which was 36, and your minimum, which was 22. And then it would complete one complete cycle at pi over 6. And then it would complete its second cycle by 2 pi over 6, or pi over 3 if you simplified. now it would go like this. It would go down to low tide, hit low tide, and come back up at pi over 6. It would then repeat that cycle down to 22 at low tide, back up for high tide by 2 pi over 6. And then that is the graph that we just looked at there. Okay. And then final, the tanker boat cannot be in the bay when the depth of the water is less or equal to 25 feet. Set up an inequality and solve it graphically to determine all points in time t on the interval from 0 to 24. Okay, that would be a 24-hour time period. So you're starting from here and going all the way to 24 hours when the tankers cannot be in the bay. Round all times to the nearest tenth of an hour. All right, so now, the way this one's going to work is this. First, they wanted me to set up an inequality. So if I'm setting up an inequality, you are going to use your equation 7 cosine pi over 6x plus 29. Now this tanker cannot go in this bay when the tide is less than or equal to 25. Okay? And that right there is your inequality. Now if you're going to solve this, basically you're going to say if this is your tide, this is your water. If the water, we'll call this here, is at 25 feet, like this, I'm going to get really graphic with you, right? If the water ever goes below this value, the tanker cannot go in the bay. So, where am I? Where am I? Where am I? Where am I? Because all of these spots represent when the tanker cannot go in the bay. Now, what line or waves did I just draw? That's at y equals 25. So if you went into your calculator, and this we already put in y1, and I put in y2, 25, you would have a line that goes across here. Remember, this is that midline that doesn't really technically exist there, right? And then you would have 4 points. Find these 4 points of intersection by doing second, trace number 5, and then you would hit enter, enter, and enter, and it would tell you this point of intersection. Then you'd move that little spider guy over here and hit second, trace 5 again, enter, 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 and then do it again, and then do it again, and do it again, and you would get the 4 points of intersection. The x value would tell you the time at which you cannot be there, and the y value would tell you the depth, okay? So if you were looking at that, right here would have been 4.2. Right here would have been 7.8. Right here would have been 16.2. And right there would have been 7.8. Okay? So when they want to know, determine all points in time on the interval when the tankers cannot be in the bay, and then round all answers to the nearest tenth of an hour. So at 4.2, and all of these, right there. And there you go. So those are your 4 points. And now if you were going to do this, you could say from 4.2 to 7.8. So from 4.2, that should be a T. So from hour 4.2 to hour 7.8, the tanker cannot be in the bay. Or from 16.2 to, I wrote 7.8 again, that should have been 19.8. To 19.8, the tanker cannot be in the bay. So from this time to this time, and that time to that time, written as an inequality, the tanker can't go in the bay because of that whole entire spot. The tide is going to be low. Okay, now we'll get a little bit easier here. So it says the height of a yo-yo above the ground can be well modeled using the equation of h equals 1.75 cosine pi t plus 2.25, where h represents the height of the yo-yo in feet, above the ground, and t represents time in seconds the yo-yo was first dropped from its max height. Determine the max and minimum heights that the yo-yo reached above the ground. Show the calculations that reach your answer. So if you think about it, this was your amplitude, and then this is your midline. So if this is your midline, I know I went 1.75 above it, and I know I went 1.75 below it. So you would just take your 2.25, which is the midline, add 1.75 for your height, subtract 1.75 for your lowest or your minimum value. So you would take your max, you would take that 2.25 and add your amplitude, and then that's going to be 2, 3, 4, right? Or 5 feet. Then you're going to take your minimum, and you're going to take 2.25, and you're going to subtract that amplitude, because now you're going down below that, and you're going to get 4 feet. Okay? So there you go. No, I mixed them up. That's what I'm doing wrong. I wonder why it didn't make any sense in my head. I have it one way on my paper and the other way on this here. So 2.25 plus 1.75 is 4, and 2.25 minus 1.75 is 0.5. That makes more sense. So those are your max and minimum heights of this function. How much time does it take for the yo-yo to return to its max height from the first time? So basically what they're asking you is how long is it going to take to complete one of its periods, right? So now we know that period equals 2 pi over b, right? So they're asking me right here to find that, right? So I know that here it is there, so I'm going to say that the period is equal to 2 pi over pi, or 2, so it's 2 seconds. So it would take 2 seconds to complete, what is this, a cosine? To go from its maximum and then to return back to its maximum. Exercise 3. A Ferris wheel is constructed such that a person gets on the wheel at its lowest point, 5 feet above the ground, and reaches its highest point at 130 feet above the ground. The amount of time it takes to complete one full rotation is equal to 8 minutes. A person's vertical position, y, can be modeled as a function in time and minutes, such that they border t by the equation y equals a cosine bt plus a. Sketch the graph of a person's vertical position for one cycle, and then determine the values of a, b, and c. Show the work needed to arrive at your answer. So you got to figure you have a Ferris wheel. Now, a Ferris wheel goes around and around, right? If you don't look at it as going around and look at it as it's going around, it's continuing to go straight, right? When the person, here's the ground, right? So this part was important. The person got on the Ferris wheel 5 feet above the ground. So this is really where you're starting, okay? Then they're going to go around. So think about it. When you're going around, so you get on here, you're going up, then you reach your highest point, and then you start going down. So that was the shape that you're going to do right there. So the person starts going up as they're going around, they reach the highest point, and then all of a sudden, they then start to come back down. And then there is what your graph looks like. What was the highest point? Well, they said it here. You're going to be 130 feet above the ground. Okay. Then, when you come back down, well, think about it. This represented 0 seconds, or 0 minutes, because the time is in minutes. And it takes 8 minutes to go around. Okay, so it takes 8 minutes to go up, and then to come back down. So then right here, you're at 8 minutes. How long did it take you to get to the top? 4. So your maximum here is 4, 130. So now I think we have all of our information to find our A, B, and C, right? So y equals A cosine bt plus c. So let's first find our c value, because that one's a little bit easier because we're just taking our maximum and our minimum. So 5 plus 130 divided by 2, 135 divided by 2 is 67.5. Now, the minimum, that's also pretty easy because we're just going to take our max and our min height, right? And we're going to subtract those two numbers. Now, it doesn't matter the order that you do it because remember, it's going to be absolute value, so our number is going to be positive in the end to begin with. And that's going to be, what is that? 125 divided by 2 or 62.5, okay? Now, what's important to understand, this was a cosine curve, right? So a cosine curve kind of does this, but since we're kind of looking at this area here, that value could either be a positive or a negative. And then our final value is going to be our frequency. Now, they're telling me it took 8 seconds to complete, right? It's going to take 8 seconds to complete this. So it's going to be, it's 2 pi over b, 2 pi over 8, or pi over 4, because 2 over 8 is 1/4. And there is your A, your B, and your C value. See, doesn't have to be super difficult. And we'll do the last question, easiest one that we have. Hit pause, try it yourself. The possible hours of daylight in a given day is a function of the day of the year. In Poughkeepsie, New York, the minimum hours of daylight occurring on the winter solstice, this is 9 hours, and the maximum number of daylight is equal to 15. If the hours of daylight can be modeled using a sinusoidal curve, what is the equation of the amplitude, right? So we just kind of did that one up top. The amplitude is your difference from your max and your min height over 2. 6 over 2, 3. There we go. Hope this helps. Let me know what you guys think, and let me know if you have any questions.